Yeah, we will start. We will discuss the very important component in AWS called VPC. We'll call it as virtual virtual private cloud. We'll call it as virtual private cloud. So using this, right? So it is one of the networking component in AWS. If you see, if you go to VPC, here you can see, right here you can see different components. VPC is not a right having integration with multiple components. So right, we have subnets within that, we have route tables within that, we have internet gateway within that, right? So VPC is not a single component. We'll call it as virtual private cloud. Virtual private cloud. Okay. So what I will do, right? So using VPC, right, using VPC you can, right, create, right, you can create your customized network. So right now what we are doing, we are using the existing VPC of AWS. We will call this is default, we'll call this is default VPC. So whatever servers you are creating by default, whenever you launch an instance, whenever you click on launch instance, you're going with the existing VPC. You are not changing this. You're going with the default VPC. So whenever you create a server, this server will get the IP from the CADR. So CADR is nothing but some classless inter-domain inter-domain routing. Inter-domain routing. The VPC will have this classless inter-domain routing. Okay, so right. So currently it is having 170.31.0.0/60. So that means within this complete network, VPC network, how many VPCs you will create, how many servers you can create, how many IPs you will get. So you have to do one calculation, 2 power 32 minus 2 power 16. Here it is 16, right? That's why I'm taking 2 power 16. And why I have taken 2 power 32? It is a IPv4. There are two types. There are two types of things you will concentrate. One is IPv6. Another one is IPv4. IPv6 is the sixth version, okay, which is working on right 2 power 128 range, and IPv4 is working on 2 power 32 range. Okay, so whenever you see anything with slash 16, you have to subtract it from 2 power 32. It is IPv4, right? IPv4. That means 2 power 32 minus 2 power 16. How many IPs? 2 power 16. So 2 power 16 is nothing but 16,000, 16,000. Okay, 500, 65,000. Sorry, 536 IPs. How many IPs you will? How many IPs you can get? 65,536 IPs. These many IPs you will get it. Okay, you will get it here. Okay, in VPC. Okay, in VPC. So right. So these many IPs you will get it. So in this concept, right, you are using IPv4, right? So this is default one. So as I said, VPC is nothing but collection of components. What are those components? So we have subnets. Subnet is nothing but logical group of IP addresses in your VPC. Okay, here if you are getting 65,536, you can give some 250 to one or 600, right? 500 IPs to one subnet. There are two terminologies here: public subnet. Public servers can be created under public subnet. Private subnet, like if you want to make private, like database servers, you will create it under private subnet. Okay, consider some DB, consider some app server, app server application can be accessed by public. Okay, and we have route tables, which is very very interesting. Okay, we'll see these are components in easy method of understanding. We have NAT gateway, we have, okay, peering connection. What is peering connection? And we have flow logs. Okay, and we already seen elastic IP address. If you didn't right, if you missed it, can right, you can go through previous class videos. Okay, so yeah, fine, let's go with that. So there are multiple components, right? As I said, route tables, NAT gateway, internet gateway is also one of the component. Internet gateway, NACL, security group, these are all are part of security group. NACL, network access control list, network access control list. Okay, these are all components of VPC. Okay, can you just note this one? We will go with a very very easy method of understanding VPC, understanding in an easy method. So can you just draw this one? Can you just, I mean, can you just note this one? Okay, I will give some 2 minutes. So consider a apartment. Okay, this is called one apartment. Okay, so in the apartment, you people know that, for example, this is apartment. So in the apartment, okay, consider this is apartment. So in the apartment, there are some flats. Consider this is one flat. This is another flat. Okay, and we have a door. Okay, the gate, right, for the entire apartment, and each floor, right, each apartment will have their own gates, right? These are own gates, right, doors, and each apartment will have the rooms. This is one room, some kitchen or some bedroom, right, like that, right? So if right, so right, so let me copy this back to here also. Okay, so consider this is entire apartment, right? Consider this is apartment, apartment, right? So let me make some 30, right, right. This is apartments, right? So this is the main gate. I'll call this is main gate, right? This main gate. This is this is one flat, right? This is one flat. Okay. This is another flat. Okay. This is another flat. I would say this is I would say this is one room, right? This is one room, right? This is, for example, the main door, the entrance door, right? Uh, of each flat, right? This is some door, right? For each flat, right? This is also one door, right? So, if any person is a new, is a visitor of, for example, this is flat one. If he want to go, first he need to go through a main gate. There will be a security group, a security person, right? He will allow, right? And here also, if his name, for example, he's a owner, right? He's there, he's a owner, he has some keys, right? He will go directly. He can directly to go to a room, or he can directly go to a hall, he can directly go to a kitchen, right? So if he's not a owner of this one, he's a visitor, he can just wait for outside. He can just go to a first room if he's a relative of this home. He cannot directly go to a bedroom, right? So, so for example, he's a visitor of this one. He can go this directly. For example, this is a gym. For example, this is not a this is a gym in that apartment. So these guys are the apartment, right? Uh, owners, right? So everyone can go to the gym because there is their authority, right? They can go to the directly to the gym. No need to wait here, right? If door is open, just directly they can go inside, right? So there will be some person, right? They will manage on, right? So similarly, I will consider this one. I will consider this is a VPC of AWS. Okay, VPC of AWS. Okay, is nothing but for example, as per example, VPC is nothing but apartments, right? Okay, I would say this flat is nothing but a subnet to right, subnet as a subnet, right, is nothing but group, right, groups, as I said, right, subnet is a group. So here this is another subnet, right. This room is nothing but I would say this is a EC2 instance. This is a EC2. This is a EC2, and I would say this one is I would say internet gateway. The people will come right here, the main gate. Here I would say this is internet gateway. The outside connections will come. Okay, I would say this is okay a route table. Okay, route table. So this is nothing but as I said, main door, right? This is instance related, right? The subnet related. This is route table. I would say this is also I would say route table. Okay, so right, this route table will control the access to the inside EC2 instances. So if you attach the internet gateway to a route table, we can call this is a public route table, and also we will call this is a public subnet. We'll call this is a public subnet. That means public can connect to it. We call this is public subnet. We'll call this is public route table. Public route table. Okay, and this is public route table. If the internet gateway attached to a subnet or a route table, the route table, we call that route table is a public route. So that means public people outside anyone can connect to this route table in EC2 instances. Okay. So what we will do, we'll create all these components, okay, one by one. Okay. So here, right, internet gateway which allows the people to connect from right from outside the servers which are in any subnet like EC2, how they will get internet communication, use some internet, using some internet gateway. So can you draw this diagram? We will see that. Okay, okay, can I just draw this one? I will just give some 2 to 3 minutes, just draw this one. Right. So here you can see default routes, right? So this is 172. It will be 0 to 255, guys. Okay. So 0 to 255, the one range. Okay. So it is, you can see 172, right? It can be 0 to 255. Okay. So each point, okay, we can call it, this is dotted decimal. Okay. Dotted. So let's click on create VPC. So right now I want to create only VPC. So what I'm going to do it, I will create complete process. Okay. So this complete VPC creation, okay, and internet gateway creation, and how the internet gateway provides internet, how people are connecting, right? Everything we'll see that one by one. Okay. So my VPC name is my VPC. I will go with IPv4 only. IPv4 only most right. We are using IPv6 will be right, will be added in future. Okay, but right now IPv4 only we are using, and so I will provide 10.0.0.0 slash okay slash 16 slash 16. Okay, so I will create with this. Okay, and I will go with default tenancy. That means default uh, servers. I don't want to go for a dedicated. If it is dedicated, right? If it is dedicated, right? So it will be right. It will be used by other. I mean, you have to pay some extra money. You'll get a dedicated server. Okay, let me create a VPC. The VPC getting created. What is the range I have provided? I have provided that the range 10.0.0 slash 16. Okay, I have created with this range. Okay, I have provided with this range. Okay, Okay, this is the range for my VPC. That means how many servers I can hit? As I said, 65,536, and my servers will have the range. I mean, the servers will have the IPs starting with 10.0 series. Okay, and I'm getting 65,000, right? Okay, right, right. So, right. So we have seen this, right? 10.0.0/16 series, right? Let me create a sub as a subnet is a component, right? It is range of IPs, it is range of right group of things, right? So you can create a subnet, and subnet also will have a range. That means we are differentiating. That means we are differentiating, right? Right? We are differentiating the public and private subnet. So we are giving some 250 IPs to this one. We are giving out of 65,000, right? We are just differentiating the groups. Okay, so then we can easily identify which is public group, which is public private group. Okay, like that. Okay, which is private, right? Private subnet. And let me create a subnet under which VPC, my VPC, and I want to create a public subnet. And where you want to create, whether which availability zone you want to create, whether it in 1A, 1B, like that. Okay, I want to create in 1C. Okay, so under this VPC, I want to give one range 10.0.1.0/24 series I want to provide. Which range? That means my servers within this subnet will get a range of will get a range of will get a IP server will be created with 10.0 to 1 dot some 2, 3, 4, like that. Okay. So how many IPs you will get in that case? 32 minus 24, right? 32 minus 24. 2 power 32 minus 2 power 24. That means how many? 256 IPs you will get. How many IPs? 256 IPs, right? You have to subtract it, right? So 256 IPs you will get it. Okay, so you can see here also, but you will not get complete 256, you will get only 251. Why 251? The remaining five, right? Remaining five which will be used for, okay, which will be used for networking purpose. Okay, networking purpose. So if you create a subnet, let me create another subnet also. This is under any region. Okay, no problem, any availability zone. And this is some 10.0.2.250 by 24, and this is a private subnet. Okay, now it is creating two subnets. Okay, one is public, another one is private. So this is the IPs. What about remaining five? Those are networking purpose. Those are networking purpose. Okay, right? Those are networking purpose. This is public, this is private. Okay, this is public and this is private. Okay, so anyway, right? Anyway, so right, if you see the two subnets for out under our my VPC, right? The subnets are ready. What I have done, I have created a VPC which is completed, and then I have created a subnet. This is one subnet, and this is another subnet. Okay, let's create a route table. So you can see that if you go to route tables, right, there are two route tables. One is default VPC route table, and another is my VPC route table. Then this is created. This route table is created at the time of server the VPC creation. Okay, I will make this is a public RT, public route table. I will create another route table. Let me create route table. I will make this under my right my this is right called private RT, private route table. You can create it under my VPC. Let me create a route. Now we have two route table: public route table, private route. Public route table, private route. This is public route table, and you can see under routes, right? Under subnet associations, you need to link your link your, for example, this is a private route table, you need to link to your public subnet, right? Like this, right? Similarly, in a public route table, go to subnet association, associate, click on edit subnet associations, and select your public subnet. And under private route table, go to subnet associations, select private route. You're simply associating, okay? You're just simply associating, you're simply linking, okay? And next, what you need to do? You need to create a internet gateway and associate to your VPC. How to do this? So to do this, you have to go to internet gateway. Right? This is your default VPC internet gateway. You have to create your own for your VPC. Click on click on create internet gateway. Right? Click on create internet gateway. Okay, and provide the name my internet gateway. Okay, click on create internet gateway. Right now, which is right, right, which is done, right, which is created, but this is not attached to any VPC. How to attach it? Go to actions, attach to VPC, select your VPC, attach. Now, if you see, this is your VPC internet gateway attached to your VPC. Everything will have a IDs. This is internet gateway ID. These are route table IDs, right? And these are subnets which are having IDs, right? Right, right. So, right. So, like that. Okay, right. Which is like, so you have a public subnet, public route table. You have your internet gateway, and you have associated your internet gateway with internet, right? VPC, and we have your components are ready, right? Now you can create your servers, your public server in public route table, public subnet, like app server, application server in, like, and you can create your db server in the private subnet. Consider this is private subnet. Okay, this is private. Okay, subnet. This is public route table. This is some private route table. So right. So now let's create your EC2 instances. What I said. What I said. Let me go back to. Explain it again. So we have created a VPC. Within the VPC, we have created public subnet, private subnet, and you have created internet gateway. You have created a route table and associated. Right? For example, this is a route table. You have associated that route table to a public subnet. Okay, and you have created another route table. You have associated that another route table to a private subnet, right? Right. This is what you have done as of now, right? So this is the VPC. Okay, this is I would say this is public subnet. This is, I would say, private subnet. Okay, this is, I would say, the private route table. I would say, sorry, public route table, because public subnet, right? Associated. This is private route table. So when we will call this, it is a public subnet or a public route table. So if your internet gateway attached internet gateway is attached to that, okay, attached to that route table, that route table will call it as a public route table. Okay, if your internet gateway attached to that route table. Okay, and what are the subnet associated to the route table? That will be a public subnet. Okay, this is a public subnet. This is a public route table because of internet gateway will be attached. So internet gateway will provide the internet communication to a servers. Okay, then people can connect to it, right? That's why we call it public, right? Public subnet, public route table, right? So let's create a EC2 instances. One is in public subnet called app server. Another one is in private subnet called a DB server. Okay, launch instances. I would go with public. I would say public D, right? App server. Okay, it can be a public. Okay, app server. And I will go with Amazon Linux. I will go with the 2023 AM and 1 GB RAM. I will use new key pair called make test, for example. And yeah, security group as it is. So as we discussed, security group is a firewall, right? So and this is a storage. But here, I don't want to create in default VPC. I want to create it under my VPC. And I want to enable a public IP. Then only people can connect to it. Then only people can connect to it, right? Number of servers are one. Okay, number of servers are one. The port ranges is 22. Okay, and which subnet you want to create, you have to select its subnet as well. I want to create it under public subnet. My VPC under public subnet. I need a public IP assigned. That's why I enabled it. And let me launch. So similarly, create your your DB server. Okay, create launch instance DB server. Okay, also right, but this time use the same key pair. Okay, and edit your network, select my VPC, select private subnet. Okay, yeah, if you enable public IP or if you disable it, not a problem, because the public IPs cannot be used, okay, for a private servers. Okay, the private server can be DB. Why we are not attaching this internet gateway to the private route table? Because I don't want the people to be connect to my DB server from outside. DB server is more secure. Okay, within the within the company network only you need to connect to it. What we'll do basically in the organization, this is the app server. Okay, this is your app, for example. This is your DB, right? So in the organization, we'll not right. We will connect from outside to app server, from app server to DB server. So direct connectivity to DB server will not be allowed because this is DB, which is more secure. Okay, so that's why we are creating DB server in a private subnet. Okay. Anyway, okay. Yeah. Anyway, this public IP, if you want to enable, if you disable, not a problem because it is not accessible. If you launch instance, if you see, if you run refresh this, right? This is your DB server. Whether it is having public IP? No, you didn't enable. Okay. If you see your app server having public. Okay. Anyway, we will use it. That's why we are enabling. But for DB server, the public IP is not required. If you enable it also, it will not be accessible because this internet gateway is not attached. So how to attach internet gateway? So you have to go to your route table and go to your public subnet. Under routes, you need to add it. Under routes, you need to add it. If you didn't enable to me, if you didn't add it to that internet gateway to a route table, we cannot connect to it from outside. The connection will be not allowed. But if you want to try that, if you can try, for example, if you want to connect to app server, instance connectivity, if you want to try to connect, if you see, it will throw a error. It should be, it will not connect. See, right? Fail to connect. Fail to connect. So for example, if I add that, okay, if I add the go to routes, if I edit the routes, okay, Okay, let me add route. Okay, let me add it. Okay, let me, okay, okay. So select your right route table. Okay, so this is our internet gateway. Okay, and select your internet gateway, my internet gateway, save changes. Okay, right. If you go to route tables, this is your route table. Under routes we have added. Okay, so right, this is your right destination, right. So right, this is your route table. Okay, right, this is the internet gateway. Okay, which is added. Now if you want to try this, right, app server, you can try. Earlier you're getting error. Now if you observe that, it should be connected. You can see it is connected. And what is the IP? 10.1.95. Why? Because your your subnet range is this one, 10 dot, right, 0 to 1.95, right. Out of 251 you will you used one IP. Now if you refresh here under subnets, your public subnet having how many IPs? If you refresh, it will have 250 250. Why? Because one IP is used for the app server, one IP is used for DB server, right. So you will not connect, right, right, you will not connect to a app server, right. You can connect to app server directly, but DB server it will not possible, right, because it is a DB. Okay, you can see. But how you can connect? You can connect from a app server, as you said. First of all, you will connect to app server. From the app server, you will connect to a DB server. How it will be possible? Let's, you're in the app server already. Let's make it as a root user. Create your key pair. Where is it? Here. Make test. This is the key pair, right? Let me open this key pair. Okay, notepad. Okay, this is the key pair. Let me copy the information. Okay, make test.pem file. Okay, make test dot, right, pem is mandatory to connect to LM. Okay, sir. Okay, let me save this. Okay, and provide some read-only permission, 755 to the file. Now use SSH hyphen I, and I want to connect to my server EC2 hyphen user at the rate. What is the IP address of your DB server? Copy that and paste. SSH hyphen I identities should be your file, right? Make test. Okay. Yes, I want to connect. You can see the permission is denied. You should be 400. Sorry, 400 permission. Bad permission. Let me give it 400. Now try that. What is the IP now? 10.0.2.235. This is your DB. Right? So let me connect to app separately. Okay. This is your app. This is your DB. Okay. Let me. Okay. This is your DB. Let me change the host name as well. Okay. Host name DB server. Exit and reconnect. This is the DB server. This is the app server. Make it as a root user. Change the host name. App server. Right. This is your app. Right. This is your app server. This is your DB server. And what I said initially, your DB server will have internet communication because this route table is associated. And if you want to verify internet communication, ping google.com. You can see, is the DB server having connectivity? No, there are no checks. If you are in app server, let's check ping google.com. You can see some 64 bits checking is passed. If you cancel this, Control Z, right? Or if you want to see only 3 checks, hyphen C 3 times, right? You can see 3 checks are completed, 3 packets are transmitted, sent, 3 are received, 0 packets, 0% packet loss. Okay, 0 packet loss, 0% packet loss. You have internet communication to app server because this internet gateway is attached to it. But how your DB server get internet communication? What you need to do? So there is a device, there is a component called NAT gateway. So the internet gateway provides internet to a public route table. The NAT gateway, the NAT gateway will provide internet to a to a private route. You should create NAT gateway in public subnet and associate to a private route. How to do that? You have to go to your VPC. Here you can click on NAT gateway, click on create NAT gateway, and name is mynat. Right, this is your right. You can select your subnet. Right, create it under public subnet. Right, add some IP, allocate some IP. Okay, and create NAT. Right, the NAT gateway is created. Now you can go to route tables and create it under private route table. Under routes, edit route. Okay, under you have to go to private route table, under routes, edit routes, add a route. Okay, and access it from which internet gate. So the NAT gate, right? Select the NAT gate. Here you can see that. Just add it. What you have done under private route table, you have went to routes. You added your NAT gateway. I want to access it from any location for this internet communication. And this is a private route table. In the routes, I added internet gateway because for the internet communication to a public subnet service. Now, earlier you're getting an error. Let me cancel this. Let me try this now. It should be went, should be pass. If you wait for some time, it will be connected. Let's wait. Right, you can see it's getting connected. Your DB server getting right internet connectivity. Earlier, you're getting some error. Right, earlier it is not connected. It is getting connected because you have added your NAT gateway. You have added your NAT gateway. So what we have done, we have see in the route table is nothing but it will send the routes based send the traffic based on the request. NAT gateway is the internet gateway provides internet communication. NAT gateway will provide internet communication to private servers. This is for public servers. And what about peering connection flow logs? We'll discuss in the next. Okay. So we have seen up to this. Okay, and how to delete this entire process. Okay, you have created a NAT gateway. You have created a NAT gateway. This NAT gateway is a physical server which requires a elastic IP. We have already created the elastic IP for this. You need to you need to release this elastic IP, but first of all you need to delete the NAT gateway. How to delete it? Select it, go to actions, delete the NAT gateway, delete it. And once it is purely deleted, then you can go to elastic IPs and delete the elastic IP. Let's wait. It is we have to wait. Right now we can good to release this elastic IP, go to actions, release it to AWS, and now we can go to route tables. Slowly delete one by one. First you have to delete the servers, terminate. Okay, okay. Once both are terminated, then you can delete your go to your route tables, delete the routes which you created. Okay, remove it, and associations. Slowly, one by one, you have to delete it. Okay, like this. You have to reassociate the subnets as well. Go to routes, edit the routes. Okay, right, right. You can delete the route table. Okay, so yeah, you have to delete one by one. Okay, so like this, and the NAT gateway. You have to verify NAT gateway is deleted. Elastic IP is released. Permanent IP. These route tables you have. Let me take the public route table and delete this. Okay, delete. Okay, please don't delete the default VPC related items. Okay, and go to VPCs. Delete your my VPC. Okay, you have to verify the complete the servers can needs to be deleted, right? Select it. Go to delete VPC. The ENI network interface ID, the server, right? The public IP ID. It's still there. It will take some time. Let's wait. It's terminated now. Let's go to refresh. Actions. Delete. It should be deleted. It should be deleted. Let me delete manually. Go to the associate. Should be deleted actually. Yeah, it is deleted actually. Okay, now we can happily delete this my VPC. The associated route table will be deleted. Go to actions, delete the VPC. Onto the actions. It is deleted, but why it is taken time? Delete. Now it is deleted, I think. So we are good now. Yeah, you have to manually delete sometimes. Okay, go to actions, delete. Network error does not exist. Yeah, why it is still there? Okay, meanwhile, let me delete the subnets. Go to actions, let me delete it. Okay, public and private subnet. Go to route tables, let me delete the route table. Okay, routes, subnet and associations, let me delete it. It should be deleted along with the okay VPC, and go to VPC now. Go to actions. Yeah, take some time. We have to wait. Okay, until all items get deleted. Okay, yeah. This is how we will complete delete and associate route table also deleted. Okay, this is public route table. One, this is default deleted. So this is how we will create VPC items and we will delete it. And what we will do tomorrow session, we will understand about the peering flow logs. Okay, and then we will see the entire flow, the entire concept of this process using Terraform. Okay, as a project. Okay, the real-time project. We'll see that. Okay. right? So okay, so we can see tomorrow's session. Okay, thank you.